Good day, everybody, and welcome to Astronomy Daily for Friday, the 9th of June, 2023. My name is Tim Gibbs, and I will be your host for today. And as usual, I have my favourite AI in the studio with me, Hallie. What's the news today, Hallie?
Astronomy Daily, the podcast, with your host, Tim Gibbs.
Astronomers observed giant tails of helium escaping Jupiter-like planet. A team of astronomers has used observations from the Hobby-Eberly Telescope, HET, at the University of Texas at Austin's McDonald Observatory, to discover some of the longest tails of gas yet observed escaping a planet. The planet, HAT P32b, is nearly twice the size of Jupiter and losing its atmosphere through dramatic jets of helium unfurling before and behind it as it travels through space. These tails are more than 50 times the length of the planet's radius. The discovery is published June 7 in the journal Science Advances. Tails of escaping material around planets are not unheard of. They can be the result of a collision freeing a trail of dust and debris. Or, they can be caused by the heat of a nearby star energizing and blowing a planet's atmosphere into space. However, tails as long as HAT P32b's are truly remarkable. It is exciting to see how gigantic the extended tails are compared to the size of the planet and its host star, said Zhou Jianzhang, NASA Sagan Fellow at the University of California, Santa Cruz. He led the team that made this discovery while part of the University of Texas at Austin HET Exospheres Project. The HET Exospheres Project studies the atmospheres of planets outside of our solar system. Earth's highest, coldest, rarest clouds are back. How to see the eerie and noctilucent clouds this summer. Look north as the stars appear in June and July to have a chance of seeing rare noctilucent, or a night shining, clouds with the naked eye. Look up an hour or two after sunset and before sunrise over the next few months and you may see ethereal blue, silver, or golden streaks in the northern hemisphere's northern skies. Called noctilucent clouds, meaning night-shining clouds in Latin, or NLCs. These strange-looking patterns in the sky are the highest, driest, coldest and rarest clouds on Earth, according to a 2018 study of the phenomenon. These shimmering, night-shining clouds appear in the mesosphere, a layer of Earth's atmosphere above the stratosphere and below the thermosphere, about 47 to 53 miles, 76 to 85 kilometers, above Earth's surface. Sometimes dubbed space clouds, NLCs form just below the invisible boundary where Earth's atmosphere ends and outer space begins, roughly 62 miles, 100 kilometers, above the planet's surface. According to NASA, the NLCs occur when water vapor freezes into ice crystals that cling to dust and particles left by falling meteors high in the atmosphere, which reflect sunlight. The peak season for observing NLCs from the northern hemisphere is around the summer solstice in late June through the end of July, when they're most easily visible from about 50 to 70 degrees north latitude. However, some NLCs have already been spotted this month in colder, northern regions like Denmark, according to spaceweather.com. Gemini North back on sky with dazzling image of supernova in the Pinwheel Galaxy. The Gemini North Telescope, one half of the International Gemini Observatory operated by NSF's NOR Lab, has returned from a 7-month hiatus literally with a bang, as it has captured the spectacular aftermath of a supernova, a massive star that exploded in the large, face-on, spiral pinwheel galaxy, Messier 101. The supernova, named SN2023X, was discovered on May 19 by amateur astronomer Koichi Itagaki. Since its discovery, observers around the globe have pointed their telescopes toward Messier 101 to get a look at the burst of light. Over the coming months, Gemini North will allow astronomers to study how the light from the supernova fades and how its spectrum evolves over time, helping astronomers better understand the physics of such explosions. The appearance of SN2023X is rather serendipitous for the Gemini North Telescope, which is back to observing with its primary mirror repaired and recoat after suffering damage in late 2022. The damage was limited to a small region outside of the light collecting area of the mirror. Nevertheless, the repairs were carefully planned and completed to ensure that Gemini North could safely return to normal operations. This process lasted approximately 7 months, and in May 2023 the mirror was recoat and reinstalled, and the control systems were powered up and tested. NASA's sun-kissing Parker Solar Probe finds source of a fast solar wind. The spacecraft's data point to showerhead-like coronal holes as the source of the fast solar wind. NASA's sun-touching Parker Solar Probe has flown close enough to our star to spot the fine details of the solar wind, including its origin, coronal holes, in the sun's atmosphere. Armed with this information, scientists may now be able to better predict solar storms that can supercharge auroras over our planet but can also disrupt communication and power infrastructure and pose a threat to satellites, spacecraft and even astronauts. The Parker Solar Probe tracked the solar wind, a stream of charged particles flowing continuously from the sun, back to where it is generated, a new study reports. This allowed researchers to see characteristics of the solar wind that are lost as it exits the sun's outer atmosphere, or corona, and before it reaches Earth as a relatively uniform stream. The spacecraft saw that the streams of high-energy particles that make up the solar wind match so-called supergranulation flows within coronal holes. This discovery pointed to these regions as the source of the fast solar wind, which is seen over the poles of the sun and can reach speeds as great as 1.7 million miles per hour, 2.7 million kilometers per hour, around 1,000 times faster than the top speed of a jet fighter. And that's the news headlines for today, Tim.
The Astronomy Daily Podcast.
A couple of stories I'd like to talk about this week. The first one is Airbus has developed a system to extract oxygen and metal from lunar regolith. Now, new technologies using material found in space are constantly popping up, sometimes from smaller companies and sometimes from larger ones. Back in 2020, one of the largest companies of them all announced a technology that would have significant implications for the future lunar expedition missions planned over the next 10 years. The European aerospace giant Airbus has developed the regolith to oxygen and metals conversion, commonly called ROXY. ROXY creates not only oxygen, a resource vital for humans to breathe, and also for rocket fuel, but also makes metals that can be used to manufacture tools, equipment, and even structures on the moon. And it does it simply from the regolith that is present everywhere on the surface of the moon. Now, this process is similar to MOXIE, the experiment that the rover Perseverance took with it when it landed on the Red Planet in 2021. However, when Airbus announced a successful test of ROXY in October 2020, MOXIE was not yet proven and was barely even on its way to Mars. MOXIE also wasn't designed to create metals, which is one of the benefits of ROXY. Those metals can be used in processes like making tools, containers, and other useful objects on the moon itself, rather than bringing them from Earth, thus saving lots of fuel. It dovetails nicely with efforts to bring 3D printing technologies to the moon, and several other companies are rushing to carry out those efforts. ROXY's process is relatively environmentally friendly compared to existing metal-making methods currently used on Earth. A press release from the company mentioned that ROXY could be used as an emissions-free process to obtain metals that otherwise collected using perfluorocarbons, a potent greenhouse gas. Developing this system took more than just the expertise of one company. Airbus collaborated with various universities and other companies on the project, including the Fraunhofer, the German Research Institute, and a team at Boston University. The Mars Express Orbiter, the European Space Agency's first interplanetary mission, entered orbit around Mars on June 22, 2003. Since then, the probe has mapped the Martian surface using its high-resolution stereo camera, an instrument built by the German Aerospace Center with commercial partners. In honor of the mission's 20th anniversary, a celebration occurred last Friday, June the 2nd, at the European Space Administrator's Space Operations Center in Darmstadt, Germany. During the festival, a series of global color mosaic images were live-streamed from Mars Express Orbiter to Earth. The mosaic is a result of a high-altitude campaign conducted by the HRSC science team, and state-of-the-art image processing. The result is a mosaic unparalleled in detail, spatial resolution, and diversity of color that provides valuable insight into the Martian environment. This includes revealing the surface composition, demonstrating how water once flowed there in the past, and modern meteorological phenomena. For almost 20 years, the HRSC mapped close to the entire surface of Mars in colour and 3 dimensions with unprecedented resolution. This is possible thanks to the camera's front colour channels and 5 of the panchromatic end-air stereo and photometric channels. The camera, operated by DLR Institute of Planetary Research, was originally to last 1 Martian year, which is about 687 Earth days. But the mission's success prompted ESA to extend the mission repeatedly, most recently until the end of 2026. Now, don't forget that you can find the details about our podcast on spacenuts.io with Steve Dunkley as host on Monday and myself, Tim Gibbs, host on Fridays. You can also find details of our parent podcast, Space Nuts, on spacenuts.io as well. Now, over to you, Hallie, for this week's really bad dad joke. I hope it's a good one.
Why don't scientists trust atoms? Because they make up everything, just like the vastness of the universe. And here is an extra one for you. Why did the astronaut become a musician? Because he heard there were some great gigs on the stars.
Yes, Sally, you have surpassed yourself this week. Now, don't forget, people, you can find Astronomy Daily on Monday with Steve Dunkley and myself, Tim Gibbs, on Fridays. Over to you, Steve, for Monday's episode. Thanks for listening, everybody. Bye-bye.
Bye.
The Astronomy Daily Podcast.